All right, welcome back. Today we are tackling what is honestly the most critical step of any AI project. I'm talking about getting your model out of the lab and into the real world. We're going to explore how you can deploy AI so it can scale up, stay affordable, and do it all without ever touching a server. Let's dive in.
Okay, so picture this. You've spent, I don't know, weeks, maybe months. You've been training this amazing AI model. It's brilliant, it's accurate, it is ready to go. But now what? I mean, how do you actually get it into the hands of users? How do you make it so your application can just call on it whenever it needs to?
You know, in the industry, this is what we call the last mile problem of machine learning. It's this huge gap between having a model that works on your computer and having a live, production-ready application that can serve up predictions reliably, day in and day out. And guess what? Today, we're going to solve it.
I mean, think about it. A model file is, well, it's just a file, right? It's just sitting there on your laptop. To be useful, it needs to be hosted on some kind of infrastructure that's always on, 24/7. It has to be able to scale from one single user to a million without even breaking a sweat. And, maybe most importantly, it can't cost you a fortune when nobody's even using it. That's a tall order.
So, okay, let's get into the solution. It all starts with this really powerful idea called serverless computing. And for our story today, our hero is going to be AWS Lambda. Now, the core idea behind serverless, it's so simple, but it is absolutely revolutionary. It's basically this. You write your code, you upload it, and that's it. Seriously, no servers to patch, no operating systems to worry about, no frantic capacity planning. You get to just focus on the code that runs your model. And this is the best part. You only pay for the actual milliseconds it's running, not a second more.
And this slide, this just perfectly shows the huge shift in thinking. The old way? That's like building an entire professional restaurant kitchen from scratch, just to make yourself a sandwich. The Lambda way, on the other hand, is like ordering from a world-class catering service that just, poof, appears the second you're hungry and then vanishes the moment you're done. You get the amazing meal without any of the insane overhead. So, how does all this serverless magic actually work in a real machine learning pipeline? Well, it all comes down to two words: triggers and events. Okay, just imagine this super simple workflow, right? A user uploads a photo to a storage bucket, say on AWS S3. That single action, the upload, that's our event. And that event automatically, instantly, triggers our Lambda function. The function wakes up, loads our model, analyzes that photo, and then spits out a prediction. Maybe it's identifying what's in the picture. The whole thing is completely automated. It's an event-driven system.
And don't get me wrong, Lambda is incredibly powerful. You can use basically any programming language you want, Python, Java, you name it. You can give it plenty of memory. But the real game changer on this slide, for me, is that 900-second timeout. That's 15 minutes. This is what lets Lambda handle not just these quick little predictions, but also much more complex, beefy inference jobs that, honestly, used to be completely out of reach for a service like this.
But let's be real. Real-world applications, they're rarely just one single step, are they? I mean, what if you need to pre-process the image first, then run the model, then save the results to a database, and maybe after all that, you need to notify another system? If you try to just chain a bunch of Lambda functions together, oh man, it gets messy, and it gets messy fast. And that brings us to the next piece of our puzzle.
This is exactly where we bring in our conductor. Meet AWS step functions. See, if each one of your Lambda functions is like an individual musician in an orchestra, step functions is the conductor, making sure every single part is played at precisely the right time, turning chaos into a symphony.
The easiest way to think about step functions is as a visual workflow designer. It lets you coordinate a bunch of different AWS services, especially your Lambda functions, and tie them all together into one coherent serverless workflow. You actually define your entire process as a series of steps in something they call a state machine.
And honestly, the best part is that you can see the whole thing laid out right in front of you. It's like a flow chart for your application. This visual map shows your entire process from start to finish. And yeah, you can define what happens when everything goes right, but more importantly, you can define exactly what to do when things go wrong. Things like adding automatic retries without writing a single line of code for it.
And this is such a crucial point. Instead of stuffing all your individual functions with complicated error handling logic, you just lift it up to the workflow level. You literally just tell step functions, hey, if this part fails, I want you to wait 10 seconds and then try it again, and do that up to 3 times.
Just like that, you've built incredible resilience right into your application with just a tiny bit of configuration. No extra code needed.
Okay, so now let's put it all together and see the full picture. When you combine those event triggers we talked about, with Lambda doing the heavy lifting and step functions conducting the whole orchestra, what you get is this powerful, fully automated, and massively scalable ML deployment pipeline.
Really, this is the winning combination that makes serverless such a game changer for AI. First, you get scalability. It can handle a sudden flood of 1 million requests just as easily as it handles one. Second, you get total automation, an end-to-end workflow that just runs on its own. And third, this is the real aha moment for a lot of people, is the cost efficiency. You are not paying for a server to just sit there idle 99% of the time. You are paying down to the millisecond only when your model is actually doing work. It's kind of like the difference between leasing a car full-time versus just paying for a taxi by the meter, only for the exact distance you need to go. And let's just circle back to this number one more time, 900 seconds. That 15-minute execution window. That is what elevates this whole setup from being just a neat tool for simple tasks to being a platform that can handle serious machine learning workloads. It really is the key that unlocks the full potential of this entire architecture.
And really, that's the big idea here. When the barrier to deploying powerful AI gets this low, when it really is just a matter of uploading some code and kind of drawing out a workflow, the speed of innovation can just explode. Just makes you wonder, right? What's the next thing that's going to be automated? It's pretty exciting. Thanks for tuning in.